Hi, I'm Kyle George, Senior Technical Sales Engineer at Liberty Oilfield Services, and today we're going to talk about clay controls. If possible, we like to start by looking at the clay composition of the formation. This is accomplished with X-ray diffraction of core samples, and an example of the kind of information that we look at is shown below. Different types of clays are affected by fracturing fluids in different ways. Swelling clays can result in proppant embedment or completely blocking off the fracture, whereas migrating clays can travel into the proppant pack, resulting in a loss in conductivity. Knowing the types of clay and the total clay content is a good first step in selecting a clay control. Liberty offers several in-house options for testing clay control, and the most commonly used one is capillary suction testing. In this test, we slurry cleaned drilling cuttings or core material with source water and different clay controls at different concentrations. We then take those slurries and measure the time that they take to move through the cylinder on the right and the rings on the filter paper. Higher CST times indicate more swelling, so we typically look for the lowest CST time for the best price. In roller oven testing, we use a similar mixture of cuttings and fluid and add this to an aging cell. The aging cell is then placed in a roller oven and rolled continuously at bottom hole temperature for 24 hours. Afterwards, the material is sieved and the percent weight loss is recorded. This tells us a little bit about the clay sensitivity and potential for fines production. Bulk hardness testing is a newer procedure that we use to look for changes in the hardness of the material. The slurry is conditioned in a similar way to the roller oven test, but then we add the cuttings to a cylinder and extrude them through it. Torque is recorded as the cuttings are forced through, and a decrease in torque shows softening of the cuttings. This yields some insight into the potential softening of the fracture face and proppant embedment. Once we select a clay control, it is often helpful to take a look at what else has been used in the area. In this example, we're looking at a map of the Powder River Basin and production data from our Frac Trends database. This area has several zones with sensitive clays, and we often compare our clay controls to KCl, which has been used successfully in the basin for many years, even though it's very expensive. However, by doing the tests that I described earlier and looking at this type of production data, we have been able to switch many customers onto Liberty clay controls, saving them an average of $200,000 to $300,000 per well. In summary, different clays need to be treated with different types of clay control. Liberty provides multiple ways to test our product's effectiveness, and our database of public frac data can be used to confirm that what we see in the lab works out in the field. Thank you for your interest in Liberty. This has been Kyle. Please go to libertyfrac.com to learn more.